Hello students, NEET important questions about chemistry. NEET important questions about chemistry means you must solve such type of questions which are related with our aspect, our subject, our concept. Question is, which of the following has strongest van der Waals interaction? Strongest van der Waals interaction between molecules of the same kind. Molecules of the same kind. This is the molecule number 1, number 2, number 3, number 4. The first molecule, you know this is 1, 2, 3, 4, 2-methyl butane. It is our first molecule. And here 1, 2, 3, 4, N-butane. It is N-butane. And it is 1, 2, 3, 4, 5. It is neo 1, 2, 3, 4, 5, neopentane. It is neopentane. And it is 1, 2, 3, 4, 5, normal pentane. These are the compounds. Our question is, nomenclature of compound is not our question. Nomenclature is not important here. Which of the following has strongest van der Waals interaction between molecules of the same kind? Van der Waals interaction, van der Waals interaction, van der Waals attraction force. These van der Waals attraction forces are important to decide melting point, boiling point of the given compound. Here, in this part, non-branching part is there. It is non-branching part and it is non-branching part. Here 1, 2, 3, 4. Only 4 carbons are there. Here 1, 2, 3, 4, 5 carbons are there. यहाँ पर 5 कार्बन है, यहाँ पर 4 कार्बन है. Both are unbranched. So here more surface area is present because one carbon is greater. More the surface area, and more the surface area, stronger is the van der Waals force of attraction. More the surface area. Surface area here is very less. Here also surface area less. Branch अगर बढ़ जाता है तो surface area. This is the surface area. ये surface area है. It is the surface area. And it is the surface area. When the molecules combine with each other, more the surface area, more is the attraction force in between them. So this type of attraction force in between molecules and molecule is known as the van der Waals interaction, and van der Waals interaction is important. So our answer is molecules of the same kind, van der Waals interaction is greater here in D. It is our first question. We will go towards next question. Okay. Yes, the next important question is, that you read this question. Alcohol, one of the alcoholic compound, and aldehyde, one of the aldehyde compound containing CHO group, alcohol containing bond OH, carboxylic acid bond C double bond OH, of comparable mass. They are having comparable mass. Comparable mass containing such type of compounds will have their boiling points related with in the order. Students, you must know that boiling point related with the force of attraction between the molecules with respect to each other. That is the such type of van der Waals force of attraction. More amount of energy is required to break such type of van der Waals force of attraction. When more amount of energy is required to separate molecules from each other, afterwards atoms from each other, there is a type of bond, there is a type of attraction force, and such type of attraction force which is responsible for stability of the molecule. If आपको बॉईल करना है तो बॉन्ड एनर्जी आपको चाहिए, सम अमाउंट ऑफ एनर्जी चाहिए. ज़्यादा एनर्जी अगर होती है तो बॉइलिंग पॉइंट ज़्यादा होगा. यहाँ पे रीज़न बताओ कि अल्कोहल, अल्डिहाइड, कार्बोक्सिलिक एसिड में बॉइलिंग पॉइंट्स का ऑर्डर क्या होगा. Carboxylic acid, we must take first carboxylic acid. Carboxylic acid group is C double bond O bond OH. Suppose it is one of the carboxylic acid. R means one of the alkyl radical. Next carboxylic acid, when they come in आमने सामने in between them, आमने सामने जब आ जाएंगे ना, 2 carboxylic acid, one carboxylic acid and another carboxylic acid, that is O bond H, C double bond O. These 2 carboxylic acids are there. When they contact with each other, when they bombard with each other, there must be a type of hydrogen bond which is to be formed. Hydrogen of first molecule, oxygen of second. Oxygen of first molecule, hydrogen of second. Means here in carboxylic acid, a dimer which is to be formed. Dimer which is to be formed, two hydrogen bonds are there. Two hydrogen bonds. Two hydrogen bonds, very important that hydrogen bonds are strong. Two hydrogen bonds are there in carboxylic acid. After carboxylic acid, we will take alcohol, R bond OH. It is one of the alcohol. And another alcohol, R bond OH. It is another alcohol. When they are come in contact with each other, they give such type of hydrogen bond. Here also one of the hydrogen bond is there. But here in this carboxylic acid contact, two hydrogen bonds are there. In alcohol contact, one hydrogen bond is there. One hydrogen bond. One hydrogen bond. And afterwards, alcohol, aldehyde, carboxylic acid. Carboxylic acid is over, alcohol is over. What about aldehyde? C double bond O bond H and here R. Here no hydrogen bonding is there. Here hydrogen bonding is not present. Here such type of attraction force in between aldehyde and aldehyde is different than type of this type of. Such type of hydrogen bonding is not present in aldehyde group. aldehyde group में हाइड्रोजन बॉन्डिंग नहीं होता. हाइड्रोजन बॉन्डिंग ज़्यादा होता है ये और इसके बाद ये somewhat aldehyde part. Aldehyde part here attraction forces are different types of attraction forces. Perfect hydrogen bonding is not present in aldehyde and in ketone also. Such type of hydrogen bonding of this part, yes, I am giving you an idea about this force of attraction is it is a dipole interaction force. It is a dipole interaction force, not hydrogen bonding force. It is a dipole interaction force. Here O minus and so negative charge and positive charges are developed with respect to breaking of this bond. Means C double bond O. C double bond O gives some type of shifting of electron pair towards more electronegative oxygen and dipole which is to be developed. So dipole reason is important here. Then our answer is more attraction force, more boiling point than this. Our answer is B. Carboxylic acid consists of two hydrogen bonds and here alcohol consists of one hydrogen bond and this aldehyde consists of such type of dipole interaction. Okay beta, thank you. We will go towards next question. Okay. Yes, it is another question related with the organic compound. Here, in which of the following carbon is sp2 hybridized state? Carbon which is sp2 hybridized state, CH3Cl, methyl chloride, NH2CO, NH2, urea, then HC triple bond N, cyanide, hydrogen cyanide, and CH3NH2, methanamine. These are the compounds. sp2 hybridized carbon means in this carbon in excited state, it combines with one s orbital of carbon and two p orbitals of carbon combined with each other. They gives three sp2 hybrid orbitals. These three sp2 hybrid orbitals are directed towards three corners of a triangle and one of the pz orbital which is in pure state. Suppose this is the carbon consisting three sp2 hybrid orbitals, 1, 2 and 3 sp2 hybrid orbitals are there. It is sp2 hybrid orbital number 1, it is sp2 hybrid orbital number 2, sp2 hybrid orbital number 3 and one of the pz orbital which carries pure pz or atomic orbital which is perpendicular to the plane containing 3 sp2. This p orbital used to form pi bond formation. by sidewise overlapping, pi bond is formed. Means, in short, in organic chemistry, double bonded carbon, which is sp2 hybridized, triple bonded carbon is sp hybridized, and single bonded carbon is sp3 hybridized. Here only double bonded carbon is here, triple bonded carbon is here. This double bonded carbon indicate that this carbon is sp2 hybridized, and this carbon which is triple bonded sp hybridized, and this carbon which is single bonded carbon. Single bonded carbon means here in this carbon 4 bonds are directed towards 4 corners of a regular tetrahedron. This type of hybridization is sp3 hybridization. So answer is B. Answer is B. Yes. Next question. Going towards next question. So it is our fourth question for this period for NEET examination. So many types of questions are there. These hydrogen bonds are not present in. Hydrogen bonds are not present in means hydrogen and oxygen and hydrogen and nitrogen. These in nitrogen and oxygen, in nitrogen and hydrogen of different molecules, hydrogen bonds are formed. Hydrogen bonding related with this. Here in glycine it is amino acid. It is one of the acid. Means in the CH4 molecule one hydrogen is replaced by NH2, another is COH. It is the glycine amino acid. When amino acid first and amino acid second combine with each other, they give the protein that with respect to amide linkage. Here hydrogen bonding is present. Hydrogen bonding because as we say that carboxylic acid and another carboxylic acid when combined with each other, two hydrogen bonds are formed. These two hydrogen bonds are indicate that hydrogen bonding is present in glycine. Here water, yes, always water is a king of chemistry. Water consists of H bond OH. Hydrogen bond is also present in water. Even if water is very important, hydrogen HOH and HOH, these are the covalent bonds, and this bond is in between oxygen of first and hydrogen of second. It is a hydrogen bond. Here also hydrogen bond is there. In C2H5NH2, yes, hydrogen is directly attached to nitrogen. One amine and another amine when coming in front of each other, they also gives hydrogen bond. And the last here, tertiary amine. Tertiary amine means here hydrogen is not directly attached to nitrogen. Hydrogen is not present. So if hydrogen is not present and hydrogen is not directly attached to nitrogen, then it is impossible to form hydrogen bond. So answer is this. Answer is this. Okay, clear? We will go towards next question. Okay.